All right, great. Now let's start our discussion. So before moving forward, do you have any questions for me? Yes. All right. How Sachin, Shekhar, Valentin, and Gridhar, do you have any questions for me? All right. All right. Gridhar doesn't have. How Sachin, Shekhar? All right. Great. So let's proceed further. All right. So yesterday, I think we were talking about accumulators. Any questions on accumulators? So accumulators are basically something like progress reporters, or they provide additions to a certain variables, or maybe logs, for example. So it's a unidirectional process in the sense that all the Spark applications will keep on sending the details to, okay, what happened here? Sorry, some disturbance. Okay, all right. So what happens is that an accumulator is essentially that are all only added to through an associative operation and can therefore be efficiently supported in parallel. All right. They can be used to implement counters or sums. Okay. And basically they can append the logs, for example. Okay. For example, let's have a look at here. Okay. So I'll say here instead of this, I'll say h1.cloudxlab.com/data/mr/word count and input. Okay. So this is what we have data. So we loaded a file and we started an accumulator. Okay, we started an accumulator with initial value at 0. Okay, so we created an accumulator and then we defined a function. Okay, we defined a function which basically updates the blank lines. Okay, so blank line is your accumulator and we are updating the blank line by 1. Okay, so when we are calling +1, essentially we are talking to the accumulator and adding 1 to the value. Okay, so when we are running flat map, so this function which you see here, the function called countBL, which we are passing to flat map, what will it do? It will execute countBL against every element in the file. Okay, So we are saying file is equal to sc.text file. Okay, so what will it have? It'll have all the lines from the big.txt. If you remember, at this location, slash data, slash mr, slash word count, slash input, what do we have? Or even this is, if your Spark is running in yarn mode, then this file will by default refer to HDFS. Okay, so we could always say file equals to sc.text file. So this file gets loaded here. Okay, and then and then this is basically an RDD. Okay, this is basically an RDD containing each line as an element. Okay, and then once the flat map is run against this count PL is run against every element or every line of this text file, what is going to happen is it's going to increment blank lines even if the this function is running across the cluster. Now imagine that what we had done essentially, let me try to show you the alternative, which could have been bad. Okay, let's say this is our file equals to sc.text file. Now we are saying blank line equals to this. Instead of that, imagine that we had done this. Okay, do you think it'll give the right value? Okay, do you think it'll give the right value? Anybody? Okay, let me save the Spark. This. Okay, anybody? So can you tell what is going to happen in this case? What will be the value of blank lines? So, okay. So this is the question to you. What will be the value of blank lines? Okay. So what are we doing here? We are basically every time we encounter uh, every time we encounter the blank lines, we are increasing blank lines by one. Will it be zero or will it be undefined? Okay, let me put it question wise. So one, zero, two, let me put zero. Second option is undefined, and third option is actual number of blank lines. Okay. Okay, let's try to actually. Okay, before we proceed, I think there is a very important question. Who can answer me this? Uh, given our given our knowledge so far, how would you count the blank lines? Okay, blank lines in file RDD. Okay, what is file RDD? File RDD is this. How would you count, not could, count the blank line? Anybody? Yes? Valentin? Arpan? Sachin? Shekhar? We'll come back to this problem later. Let's first try to count the number of blank lines quickly. So let's say we have already loaded file equals to sc.text file. Should I open it parallel? I think you guys also should all open a terminal parallelly so that I don't think it consumes so much memory. Okay. Okay. So let me just go through Arpan's attempt. Okay. I'm posting Arpan's attempt this side so that we can all see. Okay. And then I'll post everybody else. Okay. So Arpan's attempt is first read the file using sc.txt brilliant, and then however this counter will be per. Okay, let me just put it so that everybody can read it. I'm not a fast reader. Okay, so here you can see it. So read the data through sc.txt file. Good. Then run the flat map transformation and check if it's blank line or not. Okay. So do you think a better thing would be to so okay, so let me see other people's approach. Okay, only then I'll put my thoughts. All right, that's right, Shekhar. Your point was correct. Okay, and okay, Grida is saying that if the line length is 0, then it is a blank line. Correct, but I want it in terms of spark. Okay, in terms of spark, how exactly would you do it? Okay, this solution which I'm posting is from how. Okay, and the solution, it looks like this. He's doing it in a scalar. That's good. Okay, so we're saying pairs equals to lines dot map s equals to s1. Good. So we have converted the lines. Okay, counts equals to pairs dot reduce by key. Okay, but we are counting the number of lines in this. Okay, we want to count number of blank lines. Okay, so but blank lines will be lesser than the total number of lines, right? Okay, all right, good answers. All right, brilliant, Arpan. Yeah. So what Arpan is suggesting that by the way of flat map transformation, check if it's blank or not. If it's blank, then increase the counter. All right. So the approach I'm going to take for all of you, I think this approach which I'm going to take. Think about all the things. Arpan, do you have an alternative? Did you think about something else? You can improve it a little bit. Your solution will work, but you can make it little efficient. Yes, you are right. You could use filter. Anybody? Think about filter, and can you use filter to count the number of blank lines? The question to all of you is, to count blank lines, do you need to sort the data? Because say for example, I'm saying reduce by key, sort by and reduce by key is too expensive an operation. If you don't need to sort the data, if you can avoid sorting the data, it will be great. Sekhar is suggesting, okay, okay, let me just put Sekhar's answer in a single place. Okay, filter if the length is 0, good, and then group by the key. My question is, when you group by the key, it'll lead to sorting. Do you need sorting? Can't we just count it? Yes. All right. Brilliant. Brilliant answers. Thank you, everyone. All right. Yes, that's correct. How? Good. Excellent. All right. Now here is. All right. So I'm going to get into the console now and copy to clipboard and copy this one. All right. So, okay. So I'm going to open PySpark. Here we go. Now, what are we going to do is we are first going to load the data. Let's call it file rdd and say sc.text file, and we say slash data slash mr slash word count slash input. It's the same old file which we have been using for everything. Okay, so we can check if we have something there. So we have said, you see, it's the same book. All right, now let's just follow the approach which you have suggested. I say uh, only blank lines. Okay, okay, so what we do is only blank lines equals to file rdd, or first let's define a function. First define a function called get only, or we define is blank line. Okay, so whatever line you provide, I'm going to return length of the line equals to 0. Okay, so we can say is blank line, and then we say what do you call, so we say is blank line as in we say this, and you can see it says true. Or we could go a step further and we could say and strip. Okay, so let's test it out. Is it working? Good. So this is a blank line, but is this a blank line? No. All right, now let's get only blank lines rdd equals to file rdd dot keep dictating me, please. All right, keep dictating me. So file rdd dot filter, file rdd dot filter, and then we say is blank line. Good. Only let's check what is there in this. Okay, what is there in this? Now we can see, take say 100. Okay, you can see only blank lines are left. So if I say only blank lines and say count. Okay, it's going to count. Now there are so many blank lines. And also please note that the lines containing only spaces are also counted. If we did not strip the data, those lines will not be counted. We counted the lines containing only the blank lines, only the space and tab. Yes. So the U is for Unicode code. That's right, Arpan. All right. So now you can see that there are these many blank lines. Now let's do something different. Let's try to count the blank lines. How? How would you count the blank lines? In a different manner. Let's say we define a function called pass through. Okay? Pass through my data. Okay? And we have a flag. Okay? We call it, say, line counter. Okay? And we initialize it to 0. Inside every function, we define global line counter, okay? And then if, or we should say, if, what was that function which we had defined earlier? Yeah. So this is the function which we had defined. If length of this, okay, then okay, else, okay, let's not do anything else. Okay, now and let's just return, say, 1. Okay, return 0, return 1. Good. Or return 1 and return 0. Okay, so let's say we have this and we have file rdd already. So we say map and we run this function against the map. Now what would happen? Anybody? After this, if we say print, or we say new rdd dot count, okay, and then we say print line counter, okay, what would happen? Let's try to execute it. Line counter equals to 0, and then we have, okay, so we have created this function called pass through, and then we are creating new RDD, and afterwards we are trying to count this, which means the function has been executed. And let's see how many line counters are there. Do you see? Line counter has not increased. All right. Yes, that's right, Arpan. The global keyword is for making the line counter shared variable across different executors. It's not, sorry, this global does not make it shared across all the all the executors. Instead, this basically uses the global variable in due course of only this program, and that is the reason why the line counter is still 0. So on every node, the function is being executed, but on the current node, it is not executed. and that is why we are having the return at 0. Okay. Okay. So Sekhar is saying, can you make this, if we can make this as global outside and then try it out? Okay, let's try it out. Does it work this way? Okay, no, it doesn't work. You have to say, oh, do the something like this. Okay, now let's again run it, or even, should I remove this? Okay, let's try this way. Okay, okay, so you have to refer it. You have to refer it like this. Okay, if you're trying to access a function outside, so what's going on here? What am I doing wrong? Yeah, I think. Okay, so I defined global counter, then I define this function. Okay, then I indent it twice. Oh, I see. All right, now it'll be okay. Good. Now let's try to see if the value changes. So what we have done right now is we have marked it outside as well as inside as this one, and then try to do, okay, now see the value of print this one, still 0. Okay, even if I remove it from here, let's say I remove it from here, then I won't be able to use an outer variable inside a function. Okay, now what is it that what did it demonstrate? It demonstrate that this function was not run on the current node. It was run somewhere on the cluster. Okay, or it was run inside Spark. It was not directly executed. Therefore this variable is not available. Okay, so this code is invalid because this line counter does not reach outside. Does it reflect? Had you been using PySpark in an offline mode, in the local mode, line counter could have given you an answer and you would believe that this is correct result. Okay, if you are running Spark in the standalone mode, line counter could have given you the correct answer and you would believe that your code is right. So beware of those kind of mistakes. Okay, this is a very common syndrome. Most of us do these mistakes. It's very easy in case of Spark to keep on doing something offline, thinking that the things are going to run correctly on the cluster. That is why CloudX Lab also plays a very big role in learning all these ideas, because if it is running in standalone mode, it would happily give the right answer because this function is getting executed on the same machine, and therefore you will get the correct results. All right. So Arpan's point is that we would need counters like MapReduce, Valiant. So what I think is the value is defined and accessed incremented in the executor side, but these values are not passed back to the driver. That's correct. Okay, values are not updated back on the driver side. Okay, now there is a point from Srish. First create a dictionary with collection key value and then run a map function, okay, with sum. All right, that's also one approach you could use to count number of lines. You could actually count number of lines in many ways. Okay, but I believe that out of all the ways, probably filter is most efficient because it does not involve sorting the data. Okay, and it's correctly is properly distributed. Yes, that's right. So what you think here, Arpan? That's right. Okay, all right, good. So do you? Were you convinced that this is okay, this is a wrong code because this line counter is not passed back. So we talked about two things. If I have to do line counter using normal program, I can do it. Okay, but when we are going through every element, okay, we could have just simply in a single shot did the counting. If we had a global variable, we could have just updated that global variable, and in a single pass, we could have reached to the outcome. Okay, here, the one which we did, let me compare the approaches. Okay, so the way we did earlier was something like this was my approach, SG's approach. My approach was first text file. Okay, we did text file, and after that I did filter. That was one. So after we did filtered the data by that condition, then we did count. Now in this approach we are going through the whole data twice, once while going through filter and once while counting, because counting is also distributed and it passes through all the elements of the RDD. So basically counting is also kind of a distributed, and it talks to all the node and asks for the counts from every node, then every node gives. So if you see, it has two passes. Okay, this one has two passes, once for filter and other for count. Now if we have something like if this code worked, so you can see that in a single pass called map, we we could have simply done the job, right? We could have simply done the job. Correct? Sounds good to you? Now, coming back to this. So there are two passes. One we are filtering, another is counting. Okay. Filter is a transformation and count is an action. But nevertheless, when we are doing filter and then count, in both the cases, there will be two separate operations, meaning there will be two passes over the data. Okay, so that's where the accumulator comes into picture. Okay, is everybody convinced? So we talked about two approaches so far. One was one was going through first filtering the data. Before that, we talked about one more approach where we were doing the flat map and we were spitting out only the values where the lines are blank, and then we were counting. In both these approaches, using flat map or filter, in both the approaches, we are passing through the whole data twice. Okay, so what we thought was let's define a static or global variable and then let every node inform us back. Okay, let every node update this variable and then magically it'll update. But it does not work that way. This variable is only located on a single machine. It's not static. Therefore, 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 we can only we can only use the variables that are being passed. We cannot use global variables. Even if we use it, it will happily do things, but results will be unpredictable to all of us. The way it was unpredictable right now, where it gave us blank line. And interestingly, if you run the same code, run this piece of code which we are displaying here on an standalone cluster, it'll give the results. And that will be the irony. You will always keep on saying that, hey, it works on my desktop, it works on my desktop, but it will never work on the cluster. Okay? So be aware of such kind of problems. When you look at a variable, you always understand clearly that first, uh, is it distributed, is it updated by every corner? So you always, whenever you are thinking about Spark, you always think in terms of RDD, okay, not in terms of classes and objects and variables. All right. So so the what is the answer to counting blank lines? The answer is the accumulator. All right, let's define this function, and then, okay, okay, I'm not going with flat map. I'm going to simply map, because flat map again I think is too much of a headache. Okay, or even if I do filter, it that will be more efficient, because after filter, let's say I'm doing is I'm returning false. That means the value is not being passed back to the cluster, and effectively the new RDD will be blank and there'll be no transfer of data. So out of all the approaches, what I believe is, okay, so again, when we talk about big data or any problem, the trick is to think in terms of data transfer, think in terms of distribution, and think about optimization. Okay, because every second if you save in something, that will turn out to be hours. Okay, every millisecond you save somewhere, it will turn out to be hours when it comes to the big data. Okay, so let's try to use accumulator. Okay, we are defining a class called sc.accumulator, sc.accumulator, and all right, and then what we are doing is we are saying we are accessing the line counter and increasing line counter, and afterwards we are printing its value. Let's try it out. All right, let's try it out. Or one more thing we could do is we'll just return false in every case. Okay, we just return false in every case. Okay, so that it does not generate output. It's like extreme severe, what do you call, optimization. It's a tricky optimization. What am I trying to do is I'm saying filter and I'm returning false, which means none of the values will go in the new RDD. This will be blank, and effectively there'll be no data transfer while computing the new RDD, and hence it will be comparatively faster. Okay, you can actually compare the statistics. All right, so I did two things. Okay, now do you see that it gave us the right results this time? Okay, and if you see, new rdd.count gave us 0 records. All right, so you can see how much time did it take Python runner took 465 total time. Okay, 465 total time. Now let's see. That was our first attempt. So the one is filter plus accumulator is how much? These many milliseconds. Okay, or you can see finished task 0 in stage 6 in these many milliseconds. Task 1 in stage 6, 516 milliseconds, and job 6 finished and it took 565. Let me just keep that number. Okay, all right. Now let's try to do the measurement for other things. Now let's say instead of filter, I'm having map this time. Okay, and then do the same thing. All right, let's see. Is it smaller or bigger? All right, it sounds like smaller to me. It took, oh, this is interesting. Map plus accumulator is this much. Again, if I do filter, all right, this will be strange. All right. Yeah, interestingly, actually the map one is faster. Okay, it took 5.53 seconds and 0.56 seconds. Interesting. So that's against theory. Whatever I was doing is actually the filter method, the way it has been implemented, may be different, is not that efficient. All right, good. So that just disproves that filter is better than accumulator. And now, do you want to try the other one, the one which you were trying earlier? Okay, let's try to do. Okay, so the other third approach was, what was the third approach? We say, what? How did we define it? Yeah, this was the approach. This was the approach, right? Not like this. We were saying, is blank line, and we were saying return this. Okay, then we don't need this, and then we were saying is blank line and then length of this, and we say file rdd dot filter, and then we say pass through. Okay, is blank line. All right. Interestingly, this is even better. Okay, so filter and then count is actually better. All right, so it just disproves the hypothesis that as per our assumption, the first one was supposed to be faster than the second one, than the third one, but the third one is actually a better approach. Maybe when the data grows bigger, the progression here might turn upside down. Okay, all right, all right, good. Okay, so how is saying that the filter is transformation, not action? That's correct. Why use flat map to get all the words? Okay, flat map is not a great approach. Okay, we don't need to do flat map to convert the data into words. Okay, we are basically checking for the empty lines. Okay, that approach which he was talking about was little different. If I have to do the flat map, so let's say flat map function would look like this. Okay, we'll say if line. Okay, so we'll define our array. These are the new array, and we will just, okay, or you could say we could return things like this. Oh, sorry. If this, then return something, otherwise return empty. Okay, so if you do the flat map like this, the elements that will be left will be only the blank lines. I hope you got it. How would we solve a flat map? And in here trying to, okay, we are trying to basically flat map. It doesn't make any sense because we are not focused about the output. Okay, we are not focused about output. We are just focused about, so basically here what we are saying is, while we were counting words, while we were generating words, in the meantime we did the count of blank line as well. Okay, so the purpose was something else. So this flat map is serving two purposes: one, counting lines, and other, converting lines into word. That is not the purpose. Okay, all right, so good. All right, so even though on our data set this looks like strange, but okay, we will test it out to do test this out on, say, 10 GB data, or maybe 5 GB data. Okay, we'll test it out on our 5 GB data and see how this progression goes. Theoretically, this was supposed to be the fastest and this was supposed to be the slowest. Okay, but it is just opposite. All right, question from Gridhar is, how do you simulate the having clause in Spark? You basically, having is to be broken. Basically, where do you use having? You use having with group by, right? Group by X having a equals to 0, right? Select star from, give me a query, table, okay, X count star, and we say some x1 column equals to 1, right? This is the query we are talking about. How? Not how, Girdhar. So all right, so right now what we try to do is we try to show you how does accumulator work. Although accumulator was fairly successful, this accumulator was fairly successful here. Okay, so the important thing to note is, when we increased this, the moment we said line counter plus equals to 1, we are not really increasing a number. The data type of line count is not a number. It's not primitive. It's an accumulator. This accumulator provides an increment operator. This accumulator provides an increment operator, and when we are saying line counter plus equals to 1, that operator is being called. It's not that it's a number. It's not a number. It's a, okay, it's a basically an accumulator. That is why, while printing the value in the last, we did not say print line counter dot line counter. Why? Because that would give an error, because it's not allowed to access the line counter value directly. You have to increase, you have to get the data from using dot value. Okay? So that was the thing we discussed here. All right. So we will go into the details of accumulator afterwards. Let me try to answer Gridhar's question. Gridhar, is this the question you're talking about? Select X, comma, count star from table where group by X having X1 equals 0. Okay, so table, you can imagine that it's a database table. So instead of table, let's imagine that table is loaded using some text file or something. Let's just, for time being, let's assume that. Okay, so each record table is basically a big RDD containing many elements. Now, question is, how do you emulate this query? Okay, so let's try to understand what happens in case of grouping. Okay, so in case of grouping is pretty simple, right? So here, so you basically break it down into two parts. One is having x1 equals 0, and other is group by x, right? So we first apply a filter. So we'll say only with x1 0, x1 as 0, okay? Only with x1 as 0 equals, say, table dot filter and blah blah blah. Okay, so you filter the data by the function. Okay, okay, having a count. So what is he suggesting? Count star equals 0. Okay, in that case, first you group equals to, okay, we'll say here what we will do is first convert into table key value. So we will convert this table into key value using a map function. We say lambda, say record, and return, say record.x, comma, record.x, comma, record. Now you can see that we have used lambda to quickly define a function. So first of all, we need to break it down, this table, into kind of key and the whole record. Okay, now you do the group by on table kv, saying group by key. Okay, and now you could reduce it. You could reduce it with saying non zero count equals to zrp dot. Okay, now you can say here you could say map and say lambda. We could say here we'll have two things, record, sorry, x and records. Okay, this is an iterator, and then There you could simply what you do is or you could say here group by key and provide a reduce function. Okay, reduce function, maybe count. Okay, count values. Okay, and then for here you could write a map and say uh, return, sorry, you could say filter. All right, so this will do the job. Is it correct how and Arpan and Sachin and Sekhar and Shrish and Valentin? Do you think it makes sense? So the question is, how do you simulate a having clause in Spark? So it is very straightforward. The only thing you have to do is convert the table into, first load the table, then after loading the table, convert it into key value, then group it by the key. And once you have grouped the key, in the group by key, you pass the reduce function as well so that grouping happens then and there. And afterwards, the grouping is done, you filter the data. You can say group dot filter and remove the zero elements. All right. So you can say lambda. You can say x comma count, and here you could say count equals to not equals to 0. Okay, this will filter and give you non-zero, okay, count uh, ones, and then here you can collect. It'll bring it offline. All right. Do you think it makes sense? How? Sachin, Arpan, Shekhar, Shrish, Valentin. All right. So we are trying to see how can we convert a particular SQL query into our transformations and actions. Okay. So yeah, we could also do things like count greater than 0 here, or count greater than 10. All right. Yeah, you are right. Ideally, we should be doing count greater than 0 instead of saying count not equal to 0. Okay. Yeah, that's correct. Instead of not equal to 0, we could do this. All right. So everybody clear? I hope you guys will be able to uh, do the this actions and transformation on a data. You'll be able to convert. You will be able to convert most of your problems into the Spark actions and transformations. Okay. Because what I believe is that the MapReduce of Hadoop is comparatively far more complex because you have to do everything using that single MapReduce window. Otherwise, you have to break it down into multiple phases and all that. Here, that's not the case. Here, that's not the case. You have luxury of trying out many kind of things quickly and get it done. Okay. All right, so that was a little digression, but it's good. Okay, that this should give you a good confidence on the technology that we are able to quickly do these kind of complex things in couple of minutes. That does not prove that I am very expert at it. It just proves that the Spark PySpark is good. The interface is good, which makes it possible to quickly write code and get the things done. As well as Spark also provide good amount of functions. All right. So Gideon's question is, I am curious to know how to digest an SQL query if I want to write an SQL query parser. Okay, so actually, if you look at the whole query parser is actually now the grammar is open source as well as many query parsers are available. Okay, that's how Hive was written. So there are these publicly available parsers, and trust me, you would not have to do anything. Okay, so Spark SQL Spark SQL does that for you. Okay, you or okay, you can convert any dataset or data frame from Spark R. You can convert dataset or data frame from Spark R into a temp table and then run the queries. Okay, and it does the job for you. All right. But as a matter of fact, I find it more flexible than the SQL, because in SQL you have all kinds of restrictions from the SQL side. Okay, that only these functions are available, not this function is available, and for loop is not available, and while loop is not available. But in case of Spark or PySpark, you have everything available for you. Everything is available. Let's say we have to convert an XML data which is lying in SQL, and SQL is not providing an XML parser internally. It's difficult to convert the data which is loaded already in SQL into records. Okay, but in case of Spark, you can do that very easily because you have all of the Python libraries at your disposal, and you have all the Python libraries available for you. And similarly, you have Spark available which can execute any Python function. Therefore, 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 the Python Spark or Scala Spark combinations are going to replace most of the distributed computing. Okay, MapReduce was great, powerful, but it took so much time to get it done. Okay, and that's the reason why Spark has kind of replaced. Also, the most of the MapReduce code was little difficult to write. Okay, and therefore there was a hesitation from lots of people. Even the Java programmers then themselves, like myself, preferred Hadoop streaming over the Hadoop Java MapReduce. Okay, so that's why, as a technology, as a data scientist, people would the people who are data scientists or the technologists, they'll prefer this kind of technology over others. All right, all right. Although I don't have to sell it, but I'm just putting it in a crisp and clear manner. All right. So we were talking about accumulators. Okay, we were talking about accumulators. We create them in the driver. So who is the driver in this? We are the driver here. When we the this shell is the driver. Whatever function we are running here, say 1 plus 2, this is what driver code is doing. It's not happening on the cluster. It's happening on this machine because we are running by default in yarn client mode, not in yarn cluster mode. Okay, so you could say 3 plus 4 and so on. These all things are happening on the driver. So that's how you so it's important to understand what is a driver and what is the individual executor. So till this point in this code, till this point in this code here, where was that code? Here. This line is getting executed on the driver node. And then this function is being defined on the driver node, and then we are defining that new RDD is equal to this, but actual execution of this function called pass through is happening over the cluster. Okay, so Spark context.accumulator gives you the is a method that produces an accumulator holding the initial value. The return type is an accumulator object where the t is type of the initial value. So if we are saying here, if we are saying here, if we say, what was it? So if we are saying here, okay, it's not allowing me to create. Okay, so we are able to create a decimal accumulator. Yeah, all right. So looks like by default it does not provide us, but you can create accumulator of any kind. Okay, in most of the worker code in Spark can add accumulator with a method. So it only provides a method like this. Either you can get the value or you can increase the value. Okay. The driver program can call the value property on the accumulator to access its value, which is set. And if you are in Java, you can use set Java and value in by those instance method. Or please note that the method called value cannot be accessed on the accumulator. Okay, so that the workers will not be able to access the actual value. Even if they access, it will be old value and will be of no use to us. Okay, let's try to see if it makes any sense to you. So we will basically try to print line counter dot value. Okay, and here we are saying, all right, Okay, so if we say new rdd.count, okay, now you can see that accumulator value cannot be accessed inside the tasks. Okay, this is what I meant. So inside here you cannot access the line counters value, while in the driver you are able to access the value. Okay, all right, does it make sense to you? All right, you can see that we could not access accumulator value inside tasks. This is what I meant when I said that the workers can only add the value to the accumulator, they cannot access, because it does not make sense. These are only unidirectional, meaning the data is flowing from all the workers to the central system. Okay, so accessing on individual node would require a call to the central system and then access the value, which is something accumulators do not allow, because it'll be unnecessary, because it'll be like a mistake from an individual programmer, and they might end up making a making the whole system slow. So that's why the accumulator is always in a single direction. So the data is flowing from all the worker nodes to the driver. Okay, by the way of accumulator. So okay, all right. One more thing you should understand is, just like Hadoop, Spark also preemptively launches the task sometimes. Okay, you can. There are two things that Spark does which are very similar to what Hadoop does. In case while running the map or reduce, in case while running the map or reduce, it might rerun the failed task. Okay, it might rerun the failed task. Also, it might preemptively launch speculative things. Meaning, let me take a step back. So first one is okay. Let me break it down into two parts. First, let's say the count accumulator is flowing the data is flowing to the accumulator, uh, okay, continuously from all the worker nodes as they are doing their job. The data is being added continuously. Now, at the same time, one of the node fails. Half of its data to the accumulator has already gone, and now this node has failed. The same work will be started on some other node, and effectively, there might be some corrupt data. There might be more number of updates than actually required. Do you think so? So let's say there was one node which was working nicely. It sent some of the accumulator increments, okay, and afterwards that node went down. Same work was executed by somebody else, but while executing the new work it won't start from the point where it failed. It will start from the beginning. Okay, so therefore accumulator can have more number of counts. Accumulator could give more number of counts than actually expected. Okay, so we should be aware of these things. Does it make sense to you? All right, good. So it's like this, that there are one worker was working on something and it was giving update to the manager continuously. Manager was writing it down that how many hours he has worked. Okay, so manager noted it down that these many hours this person has worked. At the same time, this worker node has gone on holiday or something accident happened. Now the same work from the beginning was given to another worker. Okay, now that worker starts working on it, and that worker also gives its hours count. So the total count, the total work has taken more number of hours than actually it did. Okay, it should have without failures. And therefore, the number of counts in the accumulator level will be higher than the actual counts. Okay, similarly, manager decides that there is one worker who is very, very slow, or this supervisor of floor sees that one of the worker is very slow. What it does is, the guy who had just finished the work, he has given the same work to the other person as well. Let the effort be doubled. Whosoever finishes first, their output will be considered, because at the end of day, the manager wants to get the work done as quickly as possible. Okay, therefore the preemptive execution would also lead to duplication of accumulator counts. Do you think that's correct? All right, now you can see that, let's say this line is being executed by one of the node, say 20 times, and afterward this is dead. This data has already flown, has gone to the accumulator and has been counted. All right. So Arpan's question is, don't they have a transaction kind of concept? If they had a transaction kind of a concept, then the transaction will only be complete when the whole job finishes or the whole task finishes. Therefore, the net result of the counter would be that it'll be extremely slow. It will be only giving you the data while the work is being performed. At that point of time, it won't give you the progress. It'll give you the result at the end of it. Therefore, it's a progress monitoring. Okay, so if, let's say, as part of design, if they could have created an accumulator which will only update the driver when it finishes the whole work, that means we won't get the quick updates, and effectively accumulators half objective is lost. Okay, all right, all right. So does it mean accumulator gives wrong result? Yes, it does. Okay, in case of transformation where we need progress continuously, it gives us, in case of transformation when RDD to RDD transformation is happening, in those cases the accumulator might give you the wrong result. While in case of reduce, because in case of reduce, the overall results get transferred to the central node only when one partition finishes their work. Therefore, when the driver, when the worker finishes the work of reduce or action, of an action, only then the data comes to the central node. And that's true even for the accumulator. Okay, so in case of accumulator, the work, the communication happens to the central node only once the data is done. All right. So Arpan's question is, so the speculative execution on Spark can be disabled so that we get correct results using accumulator. But it's not only the speculative execution; it's also the failure handling. Okay, failovers or re-executions. Okay, so in those cases also the accumulator will give us the wrong result. So the truth is that it's important to understand this part so that you use the accumulators judiciously. Otherwise, if it's very critical to you, then you go through the first route. Okay, if you do not want incorrect counts, then you could basically use the actions and transformations to get the same result. Okay, if you want quick updates from all the nodes, irrespective of even if there is a minor mistake here and there, which if that is acceptable, mistake due to re-execution and re-execution of the work. Okay, if that is acceptable to you, then it's okay to go with accumulator. Otherwise, if that's not acceptable to you, you should use kind of filter map and all those things, the way the first approach we demonstrated to you how to do count the blank lines. Okay, you should go through that route instead of using accumulator. All right. Okay, so for accumulators at action level, each task's accumulator updates are applied once. Okay, so for a reliable and absolute value counter, you should pull it inside an action. Okay, inside transformation, this guarantee of correct value does not exist. In transformations, use accumulator only for debug purposes or only for showing maybe the progress. Okay, for non-critical things. All right. So out of the box, out of the box, Spark supports the accumulators of type double, long, and float. Alright. Spark also includes an API to define custom accumulator types. Okay, and custom aggregation operation. Okay, we will show you that. Say for example, while you could define a max function as an accumulator. If you are trying to find out the max value from the cluster, okay, you can use the accumulator for that also. Okay, if you are just trying to, let's say, in a single shot, while the data while let's say there is a whole process going on of word count or something. Okay, you want to find out the max value, you can use the Spark accumulator for that. But for that you will have to stitch a custom accumulator. You'll have to create your own custom incremental operation to find the max. Okay, you can custom accumulators, all they need to do is they need to extend accumulator param. Okay, all right. So this is an example, okay, which shows you how to create a custom accumulator. You could create a class in Python itself. You could say class vector. This is the name of your own accumulator, which is extending accumulator param. Okay, and it defines two functions called zero and add in place. Okay, it has to define these two functions. Okay, this function initial value will be provided to you by the way of argument, and then Okay, and then you can use this. Okay, you could add in place v1 and v2. v1 was the old value and v2 is the new value, so you could return v1 plus v2 and so on. Okay, if you are, say, trying to create the max value, you will say if v1 greater than v2, return v1, and otherwise return v2. This could be another max function. Okay, you could change this so that, all right, all right. There's a question from how I will take your previous question later. Okay, that's little off the topic, we'll take it later. All right, this one I'm taking it now. Okay, his question was related to spark closer, we will take it up later. If you do not have accumulator, only use sum reduce action, how do we guarantee to get the right aggregate? Okay, yes. Okay, so question is that while we are aggregating, the data is completely discarded from the node which has failed. Okay, data is completely discarded if a node fails. So, so the output is guaranteed to contain the right value. Okay, the data will not be wrong. It's only in the case of accumulator that accumulator does not roll back. And in transformation, we want accumulator to update as soon as the data is spitted out by each worker node. Okay? Why? Because the conversation to the driver does not happen unless the whole work of a node finishes. Therefore, we can always guarantee that the result of a transformation will be successful and will be correct. If we can guarantee it successful, then it will be output will be correct. Even if one node fails, the output will still be correct. The transformation's output is going to be correct because if a node who was in the middle of something fails, the output which was provided by that node will be absolutely discarded. Okay, in action as well as in transformation. All right, we will not accept the half cooked output. Spark driver will not take the half cooked output from the node that has failed. All right, make sense to you how now? Great, great. All right, now, okay. All right, so let's say I'm trying to keep the biggest line possible by the way of accumulator. Okay, so we could define our own accumulator. Let me try to define it. uh, all right, we will do this defining of the accumulator after the break. All right, so break for 10 minutes and back by All right. So let me start. All right. Should we start now? All right. Okay. So everybody's back. Now we can start. All right. So we can create custom accumulators in order to in order to create a new kind of uh, if you are planning, if your need is not just incrementing values or incrementing numbers, if you are trying to accumulate something else, that you can also do by having the custom accumulators. Okay, so you can basically extend the basic class and then you could increase the values. Okay, so let's try to do something. If I can make it work. So let me see if we can create something called max line. Let's call it max line accumulator parameter. Okay, and whatever two values we are given. Okay, all right, whatever initial value is given to it, so we call it. Okay, we just return the initial value. Okay, and yeah, we just return the initial value whatever it is given, and then we compute the whichever is bigger length. Let's say if length of v1 is greater than length of v2. Okay, return v1. Okay, and otherwise, sorry. Okay, otherwise what you have to do is else return v2. Okay, now this will give us a class which can uh, generate the new value. I'm doing it for the first time, the custom accumulator. That is something which is rarely done. Okay, let's try to do it again. It says accumulator param is not defined. Alright, so maybe we need to import a package. Alright, maybe we need to import a package which contains the accumulator param. right. All right. So we have to say from, I just found it out. Okay, so if you want to import accumulator, you have to say from PySpark dot accumulators accumulators import accumulator param. Okay, now it will be correct. Now we can define it correctly. Okay, so it is successful. All right, we just have to import this parent class. This is the parent class. All right, are you with me? All right, so this is the import which we were missing, and then the rest of it. Okay, so we are also saying the same thing here, and here's the class which basically retains the bigger length line with you. Okay, otherwise it'll just keep the, if there's a new value which is bigger than the previous one, then it will keep the new one, otherwise it'll keep the old one. All right, so this is our accumulator. We have just created accumulator right now, and now we are defining our accumulator like this. Okay, so we are saying initially, we are saying max, and we're passing blank value, initial value to it. Okay, and then we are passing max. Okay, all right, I think this should work. Let's see if this works or not. Okay, so this is our accumulator. Okay, so the initial value is blank, and what we are trying to do is we are trying to find the max length as part of it. So let's try to call this this function. So how do we do that? We define our own function called, let's say, a function which just does some random mapping. So let's say upper, okay, to upper function. Okay, so whatever line you give, it basically returns the uppercase of the same thing. Okay, now let's just test it out if it's working fine. Yeah, so we can see two upper Sandeep, and does it work? No, it says how do you, yeah, this is how you do. You basically say, on, you call the instance method, and that's pretty much. All right, so we just again check. Yes, it's working. Just that it's not returning anything, so we have to return the value. Now, once we have so now we have this function which we can map. Now, to upper RDD is equal to, we say our file, what was the name? RDD dot to upper map to upper. Okay, and in the meantime, let's also involve the vector accumulator. Okay, we first mark it global. Okay, then we say vector accumulator, and we say this. Okay, let's see if it works or not. All right, now let's see how many errors we get. So it says that sorry, what exactly is happening? I shouldn't have done collect, I should have done. Okay, so what's happening now? The accumulator value we need to check. Okay, ideally we could have just said turdd dot count, and then we could have said vec accum dot value. All right, let's see what is the value. See, this is the biggest line the accumulator has encountered. All right, so we were able to successfully create a string accumulator as part of this. Isn't it wonderful? So we were able to create our own accumulator, which found the biggest length out of the full file. Now, because the max is like max, finding the biggest line is an associative operation. You could use it. All right. Is everyone with me? All right. Is everybody with me? Oh, looks like I've not seek. Okay, so only so Sekhar, is it clear to you what exactly we did? We basically created our custom accumulator. You remember we tried creating a string-based accumulator and it was not working, right? This was giving some error. So we defined our own accumulator in this way. Yes, Arpan, is it clear to you? Feel free to ask. I know there'll be doubts. Arpan, how Sachin, Sekhar, Shrish, Valentin, and Gridhar. Okay. Okay. So you can think of it this way. Whenever you have to create a custom accumulator, you have to extend accumulator param, and you have to implement two methods. One, what happens for the zeroth value? Second, for what happens when we want to add two variables? Okay, all right. So So the way you can always visualize an accumulator, I'll try to visualize an accumulator. Imagine that this is a big box, okay, and many small boxes are coming from all directions. Okay, I'll make it a little better. I'll make it a little better. Imagine that there is a queue, there is a queue like this, okay, or I'll just draw something. How do you? So imagine that the one worker, second worker, third worker. These are the three workers this side. Worker one, worker two, and worker three. Okay. So these are the workers which are sending the data to this guy. Now it's sending kind of a plus. It's sending this data, and then again it'll send something else, again it'll send something else. Similarly, all of these all of these are sending some data. Okay, all of these are basically sending the data. Now this state here, there is, you can think of the final value. You can think of, let's say, this here. It can only either append these values or replace the value. Okay, so every worker at this point, okay, while these two values are being merged, this one and this one, when these values are to be merged, the add in operation happens. Whether what to do with these two values, okay, similarly what to do with these two values, okay, or what to do with these two values. Make sense to you? All right, so as we have already tried max, min, plus, minus, sorry, not minus, plus, multiply, all of these functions are basically are a valid accumulators, correct? Therefore, whether we accumulate, we keep the max or we sum it up, it's our choice. Okay, we could do here the concatenation of the string as well. Make sense to you? So this add in place, this function will get executed every time this is happening. Okay, this is happening. This is our accumulated value on the driver node. All right. So that's what we did. So we defined our custom accumulator, we defined the initialization, and we defined what happens when a new value gets added. Okay, and then we said sc.accumulator, and here is my vector. All right, so that was our custom accumulator. All right, now a quick question to all of you. So let's say we are starting a integer accumulator. We are saying accumulator equals to sc.accumulator, and then we're defining a function called g, accumulator.add x, return some function fx. Now when we say data map g, print accumulator dot value. What happens to, what is the value, what is the final value of this accumulator? Quick question. I know it's a teaser. Okay, it's a teaser. So be ready with an awkward answer. Okay, anybody? It's a teaser. Okay, so that should be a good hint. Arpan, Shekhar, how? Sachin, do you think what will be the output of this one? You've already tried a couple of times. Now, since I've not provided any information on what is inside data or what is the function fx is doing, it means that those values are irrelevant. Okay, all right. Sachin, please give the reasoning as well. Your answer is right. Yes, yes, Arpan, your answer is also right. I'm not going to announce the answer yet. Correct, correct. You are right. How? Yes, yes. That's correct, Sachin. Brilliant, brilliant. Okay, quickly, Arpan. Your answer is right. So, all right. So, so the value of accumulator is evaluated only after an action, not after transformation. Transformation does not mean anything until you run an action. Okay? Transformation is like, I've made a note of it, do something. Okay? So a transformation is that operation. So this map operation is a transformation. So it is just, Spark just noted down, okay, you intend to run G on every element of data. That's okay. We'll run it, but first tell me what is the action. So until you execute an action, Spark won't do anything. Okay. Next is, all right. So that was accumulator. So what are the things we learned as part of accumulators? Accumulators is great to get the progress from all the nodes. Okay, and it happens near real time. Okay, so the accumulators data keeps on getting transferred to a central place, so you can display the progress. But accumulator cannot be used. Accumulator can have minor mistakes if re-execution of a task happens, or some the speculative execution happens. In both the cases, the accumulator will result in a wrong value. Next is we can extend accumulator. Okay, we can extend accumulator, and we can have any we can customize it as based on what we need. Okay, All right. While the transformation, the result of accumulator as part of transformation is very correct. All right. So here, okay. All right. So now the other aspect of Spark programming is the broadcast variables. Okay. What is a broadcast variable? Just like we had counters in MapReduce, we have accumulators here. Similar to the distributed cache, we have broadcast variables. Okay. So let's say in our word count example, the one which we have been running for quite some time, in our word count example, we want to remove the common words. And common words is a big list. So what would be the right way to remove the common words? Okay, give me your approaches. Okay, question is how to remove common words in our word count example. Anyone? If we have a list of common words, what are the ways of removing these common words? All right. Anyone? Good, Sachin. Keep go on. Good, Arpan. All right. Okay. All right. Let me put it now. Yes. How and Gridhar and Valentin and Shrish. Shekhar. Okay. So Sachin's, I'll just consolidate. Sachin's approach is get the words, get the words in an RDD, okay, and then use with custom function to compare with the common words. Okay. Okay. So what you're suggesting is the hard code the words into the filter function, isn't it? Right? All right. Now let me just see what is Arpan's approach. Arpan's approach is read the true file and create an RDD. All right. Sachin, your approach is correct. There is no doubt about the approach. Okay. Definitely your approach is correct. All right. Now read the true files and create RDD. Loop through the common words, put it in the map. And while checking the word count, look up in the dictionary and skip the word if present. So do you loop through the RDD? Because if I understand, you've created two RDDs. Okay, so Gridhar's approach is the create the flat map of two files by words. Okay, then do some minus operator. Good, brilliant. We can create a key value pairs and then we can do the set by operator. Good, good. So that's a good approach, Sachin. All right, there's no doubt about it. I'm just trying to understand. Okay, so the Arpan's approach is loop through common words and put it in the map while checking through the word count. Okay, okay. So I want to understand that are you looping through the common words? RDD? Is it an RDD? All right, good, good. Yes, this is right approach. All right. So you could so here itself, while in the code itself, you are loading this data. All right. All right. All right. Any other approach? So the first approach is that we loaded this file. We loaded this data as an array, hard coded it. Okay. The second approach is from Gridhar that you load these two as an RDD and then use subtract set by operation. Good, brilliant. So both the approaches are correct. Just that in the second approach, this one, we are doing the set based comparison on two big data sets. On one big data set, another very small data set. Okay, so in these cases, a better idea would be to remove these common words. And if you remember correctly, so in the approach where we are loading the two data sets in an RDD, the set by operation would internally be sorting the data, and effectively the approach will be slower. So a better idea would be to either hard code or in some way read the data and then pass it over. Okay, and that's where the broadcast variables come along. All right, so the approach which Sachin and Arpan has suggested that load the data into the memory and then iterate over the words in a map. In a map, you keep on removing the words, or in a flat map, or in a filter. In a filter, we remove the words which we don't need. Okay, so that approach is inefficient because Spark sends all the reference variables to all the workers. Okay, so the default task launching mechanism is only optimized for small task sizes. The objects which you are passing to map function, the variables which are you are passing to the map function, those are optimized only if your objects are small. If your objects are really big, then it's going to be very inefficient. Okay, if you have used the same object multiple times, Spark will be sending it again and again on all the nodes. Okay, why? Because it doesn't know that this variable is having the same value or different. All right, while in case of broadcast, this part is optimized. All right, so why do we use broadcast instead of local variable passing? All right, So broadcast variable looks like this. This is your driver from where you've started the process, and from the driver you are sending the process to sending the data to all the nodes. Okay. So when you say broadcast, the data goes to all the nodes, and if the data is already sent, it doesn't send it again. It is very heavily optimized for communication between all the nodes. Alright. Also, broadcast sends the data only to the node which will be involved in the process. So broadcast variables allows the program to efficiently send a large read-only value to all the worker nodes. For example, send a large read-only lookup table to all the nodes, large feature vector in machine learning program. So what does it mean by here? So in any machine learning programs, this is very much required, because what happens is that based on the past data you have done some training, and that training had generated certain that training had generated in certain vectors, certain machine learning model. Now we can send this machine learning model to all the nodes so that we can run this model in real time against real time data. Okay, that is another use case. There are many use case for broadcast variable. So it behaves more like a distributed cache in Hadoop. Spark distributes broadcast variable efficiently to reduce communication cost. Okay, it is very useful when tasks across multiple stages need the same data. Okay, so if the same data is required somewhere in the map, somewhere in the filter, somewhere in the other process, then broadcast variables are very useful. Okay, and caching data is in deserialized format is required. In those cases, deserialize is in something that can be saved into disk. All right, so you can see that we could have the we could create a broadcast variable like this and execute it. Okay, we could create the broadcast variable like this and execute it to remove the common words. Okay, so you can say what we have done here is we've defined common words as an array. Okay, so instead of just referring common words everywhere, what we are doing is we are, after loading the RDD, we're defining a function. Inside the function, we are talking to the broadcast variable. Okay, the way you talk to broadcast variable is by dot value. Okay, we say whatever is our broadcast variable. For example, here common words bc dot value. All right, and here we are using this variable like this. We are saying if word is not in, then do this. All right, so this is broadcast variable. Using broadcast variable you can send the data to all the nodes. All right, now working on per partition label, that is another concept where you want to run your code on per partition. Sometimes it's very much required that instead of running the whole process again and again on all the nodes, you could actually run something on per partition. There was a discussion earlier, why do we require per partition basis things? The reason is, the reason is, let's say you are trying to initialize some database connection or something. You don't want to initialize this database connection again and again for each variable. Instead, you want to initialize this database connection only once for, or maybe only once for whole cluster, or only once for each partition. If your data has got 10 partition, there will be 10 connections to the database. Okay, so you can define, you can do that. It acts as if it's a connection pooling. All right, so you can do that. For example, let's say there's a function called process which processes signs. Okay, so first of all, you create a pool manager using URL 3. Okay, and then this is map function is from, not from RDD, but it's from Python. So we are running this method on every element of science. Okay, on every element of science, meaning we are creating URL for all the science. So if you have A, B, C, D, E, F sign, then it will result in this URL where A.json, B.json, C.json, and so on. So many URLs will be there. And next, we again execute another map. What it does is it makes a request to that URL and brings the data. Now this request will have the results of all the HTTP requests, and at the end of it, we could load the JSON data by using JSON loads, and that's our data. Okay, and so on. So what's happening is that we are making a call to this URL in every node. So if a sign is already called, or if we can, if there is an API which requires multiple signs and can give us the result, then we this is not optimized because it's being called for each sign. Okay, and then we are removing the result which is none. Okay, so this exactly, what is this? This is not, this has nothing to do with the Spark code. This map is Python's local map function, and filter is also Python's local filter function. Now this function, whatever signs you give it to it, it will call this URL, download the data, load the data in JSON, and remove the empty records. Okay, remove empty records and then give you the result. So even if you give 100 signs, it will do all of this 100 times and give you the results. Okay, now if you want to fetch now you could either call this process method on every element of, either you could call this function on every element of the node, or you could call this function only on few nodes. Why? Because here this pool manager is created on every call of process. So if you are calling this process on every element of an RDD, this pool manager will be different for every element. There is no benefit of having this pool manager in place. Okay, therefore if you call this process on many elements in a single shot by using fetch call signs, okay, by using map partitions, if you use map partitions, then this process function will be called once for each partition, and then if you have multiple signs, then this HTTP pool manager will be initialized only once for each partitions, and the signs will be processed by the pooled one. Okay, so this is how we already have a brief discussion on how to use map partition, but this is a good use case or a good example to do that. Okay, sometimes we need to handle the legacy code. For example, we might have to make a call to our library, or we might have to make a call to some other legacy, say octaves or say MATLAB, some other data you need to pass it to. Okay, so in those cases you can actually call a legacy function from within the map. Okay, all right, so for example, let's imagine that this is my R script. Let's imagine that there is this function which basically is in R script. So this particular the first line of any program tells Unix that how to execute this program. If you see user bin env R script, this program, if given this program as an input from stdin, will be more than happy to run it. Okay, so this R script will run this program and give the results, but we don't know what is in this program, because let's say you do not know what is R, you do not know how to translate R into some other language. Therefore, translating this legacy code is out of question. So you can use this R program. Okay, you could use this R program to call to basically, okay, to you can use this uh, R program to on every element of a RDD. Okay, so for example, let's say there is this program which need to be executed from your MapReduce. So what you could do is you could you could say add file. Just like distributed cache, this file will be made available on every node. So first thing you do is whatever program you are trying to execute on every node as part of map function, before creating an RDD or before executing things, you need to add this file to the Spark, meaning this file will be taken to all the nodes and will be made available there. Because to execute a file on every node, you need to first take the file to every node, and then second step is to execute it or prepare environment for that program. Okay, so here you can see that whatever is happening, we don't care. Here is some, okay, here what I'm trying to show is you could simply say spark file dot get, and it'll give you the file wherever you need it, and then you can run this using pipe function. Okay, so you could create pipe inputs using methods like this. Okay, and then you can call pipe inputs to pipe. Okay, pipe inputs is a list of inputs given to the pipe commands. Okay, all right. So basically, it's a brief description on how can you execute an external function as part of map function. Also, there is nothing wrong in inside your Python program, you can directly execute a script. All right. And there are some numeric RDD operation which you may like to use it from time to time, such as count, such as mean, such as sum, such as max, min, variance, sample variance, standard deviation, and sample standard deviation. Okay, so these are provided because these are very frequent works of an of a data scientist. So if you have, say, this value 1 comma 2 comma 3, so you could load a RDD as sc dot parallelize, Okay, so you could do that by sc.parallelize, and then you could on top of this RDD called AR, you could call these functions which are related to the statistics. For example, we could say standard deviation stdev. So you can see that it has computed the standard deviation. Okay, so all these functions are available as part of the basic RDD operations, and this can be only executed if the RDD contains an array of numbers. Yes, pipe will execute any program which can be executed on the operating system. All right. Okay. So let's say you have a very big data and you want to remove outlier. Outlier is somebody which is three standard deviations away from the mean. Okay. So how do you generally find out who is outlier? Outlier is somebody who is greater than three standard deviation away from the median. Okay, those who are not aware about statistics, let me give you a quick view. So on a given data, you generally find out how are the values varying from the center, and that is well done using standard deviation. You first compute the mean, and then you compute the overall deviation uh, by various values from the mean. Okay, and that becomes your, after dividing by the total number of values, it becomes your standard deviation. Okay, so standard deviation is a very good measure. If your son comes to you and says, hey, I got 85 marks, okay, if you are a statistician, you should not be happy unless you know what is the standard deviation in his class and how many standard deviation away is he from the best. Okay, so you can simply create an outlier and test each value against standard deviation. All right. So these were few advanced operation which we talked about on top of Spark. So today we talked about accumulators. We tried to compare the three approaches: one with accumulator, one without accumulator but using map, and then other without this thing but using filter. So we use those three approaches to see the difference, and but interestingly there was a difference in against our hypothesis. Probably that can be well tested when we have bigger data. Okay, then we talked about, after the accumulators, we talked about the broadcast. Also we talked about various kinds of operations on broadcast and the reasoning. All right, and then we talked about other aspects like piping to external programs and working on per partition basis and so on. Okay, and numeric operations on RDD. So these were some of the operations, advanced operations on RDD. Okay, all right. So there's a question from how, let me just show you that. Question is, why approach 1 is faster than approach 2? I think map is quicker than the filter for the case because map operates on each line of a file. Okay, and increment accumulator counter if blank line found. Okay, Yes, that's a very good reasoning. That's a very good reasoning. Okay. Yeah. That is a very valid reasoning, because filter needs to evaluate a condition, and evaluating a condition as opposed to assigning something to something is generally more CPU intensive. So probably that's the reason why filter might have been slow. Good, very good. How? Yes, that's right. All right. So yes, that's correct. All right. So moving to further details. All right. So let's take another look at how to run things on cluster. It's a small topic, so we should be able to finish it very quickly. Okay. And then we would move to other aspects of Spark, such as Spark R, and probably we will have to extend to Spark R. Okay. So in the previous syllabus, we have not covered Spark R, but this time we'll be covering Spark R. Okay. For that, we'll be checking if we need to install the latest version of Spark, or can we upgrade Spark. Okay. All right. Let me make a note of it. Install latest version of Spark that has Spark R. All right. Any questions? All right. So Arpan's point is pipe thing is not very clear. Okay. So let me just take another look. Probably I think what I should do is I should take up a simpler example with the pipe, because the example which is given here is little more complex, and even it's not demoable. That's the reason it's not clear. Let me see if I can pull something and make it run. Okay, let's start from this side. So here we are saying pipe inputs dot pipe. Okay, and then we are saying that this is the script, please execute this script. Okay, the important thing to understand is that this script takes data from standard input. Okay, you can see that file f equal to file standard input. So this R program reads data from standard input to standard output. Just like Unix commands, it reads data from standard input, does some processing, does some distance computation here, and writes out the distance. So basically, before you execute things, okay, so let me just try to find out what does this contact list contain. Okay, so let's say there is an RDD, key value pair RDD. We are fetching all the values from this RDD and then running a flat map. What does flat map do is it basically is converting this data. Okay, okay, basically here we are preparing, we are preparing. Okay, so this filter has distance information. Verify that a call has field that are required to compute distance. That's okay. And then the format call. It's converting it into saying my lat space my long then contact list and so on. Okay. So all right. So it's very straightforward. Okay, straightforward. This is one RDD that contains the data that can be put to a standard output. Okay, it's, you can think of this pipe's input is a big, something like a big, the input in this format. Okay, first line, second line. Okay, let me try to execute something. Okay, so let's say there is, let's let it take time. So this is my array of input. Okay, now I say my in RDD equals to sc dot parallelize array. Okay, in RDD is my data. Okay, now we can do in RDD and say pipe. Okay, we can say pipe on this data. Alright, let me say that I just want to execute WC against my program. Okay, so let's say I want to execute a Unix command called WC. Okay, let's say this. Will it work? Let's say out.collect. Alright, did you notice something? I think this is far better example. Let me just put it in a separate file and give it to you. Okay, what did you see just now? There is this file called array. Okay, okay, and then say out.collect. Okay, so what exactly is happening? So this WC command, what does WC do? Anybody? If you are from Unix, okay, if you are Unix, you would know what does WC do. Anybody? Word. Yes. So basically it does a character count. All right. So if we do an echo this and pass it to WC, we get this result. And you see, it's the same result we have here. Similarly, when we say echo this, we get the second result. See that? So what exactly is happening? When we are saying sc.parallelize, we are converting this array into an RDD. And then what we are doing is we are running every element of this RDD through the program here. We are running every element of this RDD through this program. Alright, and then we are saying out.collect. Is it clear? This is the only program right now what we're talking about. Yes, so it's like an action. It's not an action, it's basically a map function. It's more like a map function because it runs only after we said collect. Okay, so instead of a lambda function, that's right, instead of a lambda function, we are using a Unix command called wc. Yes. So basically, this pipe is executing this command. Had you been running on Windows, then and you have copied that wc.exe from Cygwin, you would use .exe here. Okay. So this way you can execute any command whichever you wish. Okay, whichever you want, you can execute that command. Similarly, let's try to create a cell program. Let's try to quickly create a cell program, and let's say we have mycmd.sh. Okay, so what does this mycmd do? Whatever you say to it, say Sandeep Giri, okay, it converts it into it converts it into okay, it converts it into two lines. That's it does. Okay, you can see that it has converted whatever we say into multiple lines. Okay, and if we have special characters and we have some minus plus, it'll remove those and convert everything into lowercase. All right, so we can execute this command as well. Make sense to you? We can execute this command as well. So let's try to execute this command from here. But for this to happen, we need to first to push this to the all the nodes. And how do we copy this to all the nodes is using add file. And in the add file, we say what was the script we were dealing with? We were dealing with this script called mycmd.sh. We say mycmd.sh, and inside wc, instead of wc, we say dot slash dot slash means current directory dot sh. Okay, this is a better example, and let me just put some more special character and some capitals. Okay, and let's see if it works or not. Okay, now you can see that it worked smoothly. So it says, okay, oh, I made a mistake again. That's the reason I'm getting the wrong result. Now you can see that this this has been converted into this. All right, you can see that this. So first, so it basically it is more like a flat map. Okay, it's more like a flat map. All right, does it make sense to you? Yes, go ahead, please. Is this clear to you? Let me try to undo this. Yes, go ahead, Arpan. Okay. Arpan's question is, why did we add sc.add file? Why did we do this? Can anybody tell me? Why in the first program, this one, you can see this program we did not run sc.add file. Why did we run this? Anyone? Quickly. Have you used Hadoop streaming earlier, or have you used any other say Pig or Pig UDF or something like that, right? Oh, Pig streaming you have not done. All right. So in all right, I'll try to be straight. Good, good question. Anybody else answer? Yes. I look forward to your answers. All right. So yeah. Anyone? All right. Let me explain. So in the first program, this program, you see here, in the first program, we did not need to worry about shipping this program everywhere. Okay. While in the next program, we had to ship it. Why? Because WC command is available on all the nodes. The WC command which we are using is available on every node in our cluster. So we don't have to install it. We don't have to copy this command and install it on that machine. But in the other case, the second case, where we created our script called mycmd.sh, we had to kind of install this mycmd.sh on every node. And when I say install, it doesn't mean like we are running a setup wizard or something like that. Here, what I mean is we'll have to copy this file into the folder, into the current local working folder. Okay, in the current working directory, whatever it is, the Spark will copy these scripts. Okay, there could be a scenario. Let's say this mycmd.sh is making a call to say some other command. Okay, let's say we have mycmd.sh. Okay, we have say mycmd.sh, and and let's say this part of the program. Okay, this is mycmd2.sh. Okay, let's say mycmd.sh is making call, is not doing translation. Okay, let's say my program is broken into two scripts. Okay, my program is broken into two scripts. Okay, all right, so we say chmod and mycmd2.sh. Okay, now Let's say my entry point in this scenario is my cmd2.sh, but internally my cmd2.sh is internally using my cmd2.sh is internally using my cmd.sh. So wherever we want to run my cmd2.sh, we need two scripts. One, mycmd2 as well as mycmd. Both the scripts we need on the machine where we want to run this mycmd2 command. Okay, so in this case, in the third scenario, you will have to ship both the files. You will have to ship both the files like this. Okay, we'll have to ship both the files, but only execute second one. Okay, only execute second one. Let's try to show you. All right, so it says that this mycmd.sh already exists and does not match the content of mycmd. Okay, so we are okay. So that's interesting. It did not let. Okay, let me just exit once. Okay, in a session, if you try to copy it again, what's happening? So it says that exec format error. What does it mean? Oh, this CMD is already copied to everywhere. Okay, so that is the reason. I think we have to remove this file. Is there a remove function? I think there is a remove function. SC dir sc. Do you see any remove anywhere? We have clear files. Let me just say clear files. Yeah, that's better. Good. All right. So it has cleared everything for me. And now we are running the same thing. What is wrong with this? Did we make a mistake somewhere here? My cmd2.sh. Okay, this is correct. All right, never mind. It's just that, yeah, it's just some formatting error, nothing much. So all I was trying to show you is you could ship multiple programs and get them executed. All right. All right. Now that is so. I hope that's clear to all of you. So question from Arpan is that could we have done it using the broadcast variable? The quick answer is no. The reason is you have to copy this file to the local folder. Okay, so it's easier to basically use add file instead of putting it into broadcast variable and again reading it everywhere and then installing it. So then you could have run into the other issues. So, do you install it on every map or do you run map partition? Okay, because for each partition or for each node, this file will be copied only once. Very good question, Arpan. Thank you very much. And keep these questions coming. These questions are very important. Yes, it's basically kind of the stdio, any stream handling like SED. Okay. All right. I hope this part is clear. This is very important because it invariably you will be in a situation that you want to either use Unix commands quickly or you want to use some legacy code. And this is quite useful. This is very useful in those scenarios. All right. So, okay. So try to run whatever we have discussed today. Please try to run it by yourself. That will give you a good confidence. Try to measure and calibrate which method is better on what kind of data. All right. So please go through these examples, whatever we have done today, so that you can start running. Because otherwise, what happens is, even though things look very simple when I'm doing it, but when you start doing it in a real life, the things do not go the way you would expect it to go. Okay. All right. So please do not assume that things will just work like this so smoothly. Try to do it again and again, and you will have the thought clarity. All right. So stay connected over the week. You whatever your problems you have, keep sending emails. Okay. And if you, once you are done with questions, let me know. I'll be sending you more exercises to work over the week. All right. So quickly finish your quizzes if you have not touched earlier. So that we will give you more assignments to work upon. All right. Have a great day. Thank you, Gridhar. Thank you, How. Thank you, Arpan. Thank you, Sachin. Thank you, Sekhar. Thank you, Shrish. And thank you, Valentin. Have a great week ahead and stay connected. All right. Bye bye. Have a good day. All right. Great.